Hi. Let's see the application of Z transform. That is, we are going to solve difference equation, and these are the steps. So step 1, we have to take Z transform on both sides of the given difference equation. Step 2, we have to use the known formula for the Z transform. For example, if it's un plus 2, then what is Z transform of un plus 2? Z square into u bar of z minus u0 minus u1 z bar minus 1. That's it. So similarly, on the left hand side and right hand side, whatever known expressions are there, you have to substitute. Step 3, obtain u bar of z in terms of un. Okay, so here one more thing is there. Sometimes they will give initial values. If they have given initial values, in step 2 itself you have to substitute initial values. So you can include this line in step 2 along with this, substitute the initial values if given. Okay, then you can segregate u bar of z, and right hand side it should be a function of z. And finally, step 4, apply Z transform inverse on both sides to get un. Okay, so u bar of z is nothing but Z transform of un. If I apply inverse, I will get un. So these are the steps involved, and remember the formulas. You have to be very much thorough with the formulas to solve these difference equation. Let's see one example. First, I will go with a very easy problem. That is, solve the difference equation un plus 2 minus 5 into un plus 1 plus 6 un is equal to 36, where u0 is equal to 0 and u1 is equal to 0. Okay, so what is the first step? You have to apply Z transform on both sides. So this is step 1. So Z transform of 36 on the right hand side, Z transform of, what is the first term? un plus 2 minus 5 into Z transform of un plus 1 plus 6 into Z transform of un. So what is Z transform of un? That is u bar of z. Here it will come, and this is plus 6. So see here, Z transform of un plus 2. This is the first term, right? So we are taking z square common, u bar of z minus u0 minus u1 by z. This is the formula. Second one, minus 5, we are taking it outside. Z transform of un plus 1. Okay, what is the formula for Z transform of un plus 1? U bar of z minus u0. Here it will be like this, 5 minus 5z, u bar of z minus u0. Since here u0 value is 0, they have written directly. They have substituted u0 as 0. And the last one is plus 6 into Z transform of un. What is the notation? U bar of z. And right hand side 36 is just a constant. Take it outside, Z transform of 1. What is Z transform of 1? Okay, it's not visible. Yeah, 36 into Z transform of 1. Z transform 1 is nothing but z by z minus 1. So now on the left hand side we have to simplify. u0 is also 0, u1 is also 0. So z square into u bar of z minus 5z u bar of z, and plus 6 u bar of z. So we are taking u bar of z common outside. Z square minus 5z plus 6, that's equal to, on the right hand side, 36z by z minus 1. This is nothing but a quadratic equation, and this is z minus 3 and z minus 2. So please be careful. If you are getting confused, you can multiply and check. Minus 3 into minus 2 plus 6 minus 3z minus 2z, I will get minus 5z, z into z, z square. So z minus 3 into z minus 2. So now step 2 is over, and we are going to segregate u bar of z. So u bar of z is equal to, pushing everything down to the denominator, 36z by z minus 3 into z minus 2. Already we have z minus 1. Now if you see this is something similar to your partial fraction problem that we have done so far. This is a very easy problem, and as I told you here, denominator everything is linear and the power is 1. So there is no problem. It's a direct formula format. So we can preserve this z, push it to the other side, and we can write a by z minus 3, b by z minus 1 plus c by z minus 2. You have to resolve it into partial fractions. And what is the common LCM? Z minus 3, z minus 1, z minus 2. Whichever is not there, you are going to multiply. Correct? So 36 by denominator, actually 36 by denominator, this thing by denominator. Denominator and denominator will get cancelled, that's why we didn't write it. So here z minus 3 is there in the denominator, which is missing z minus 1 and z minus 2 multiplied by that. Here z minus 1 is there in the denominator, which is missing z minus 3 and z minus 2. So we have multiplied by that. Last one, z minus 2 is there in the denominator, which is missing z minus 3 and z minus 1. So we have multiplied with that in the numerator. So denominator, we will get the LCM of all the three, and then that will get cancelled. So we get 36 is equal to all these things. Finally, if I substitute z as 2, a will become 0, b will become 0, and c will become 2 minus 3 into 2 minus 1. So 2 minus 3 is minus 1, and then 2 minus 1 plus 1. So minus c is equal to 36, therefore c is equal to minus 36. We got c. And similarly, if you substitute z is equal to 1 in the above equation, a and c will become 0, b into 1 minus 3 into 1 minus 2, that's equal to 36. So 2b is equal to 36, b is equal to 36 by 2, so which is nothing but 18. So we got b as 18. And the next one, if you substitute z as 3, if you substitute z as 3, this is very easy. B and c will become 0, you will get a, so 3 minus 2 into 3 minus 1, so here 1, then 2a. So here you will get 2, so here we will get 2a, looks like 2a is equal to 36, so this value is also I think 18. So finally, when you are segregating this, a by z minus 3, that is 18 by z into z by z minus 3, plus b into z by z minus 1, then last one c is minus 36 into z by z minus 2. Now if you apply the inverse, this is z by z minus k, right? K power n. So here k is 3, so we have written 3 power n. K is 1, so we have written 1 power n. Minus 36, here k is 2, so we have 2 power n. This is a very simple and easy problem. Now let's see more problems. Now let's see this problem. The equation un plus 2 minus 2 into un plus 1 plus un is equal to 3n plus 5 is satisfied by a sequence un. Find the sequence using Z transforms. Here they didn't give any initial value. Okay, so this is the first thing you have observed. So step 1, we are going to apply Z transform on both sides. So Z transform of un plus 2 is z square into u bar of z minus u0 minus u1 z power minus 1. Second one, minus 2 into z transform of un plus 1 minus 2 into, what is z transform of un plus 1 formula? Z into u bar of z minus u0 plus z transform of un. What is z transform of un? Is nothing but u bar of z. So we are done with this left hand side. Now moving to the right hand side, we will have a first term 3 into z transform of n. What is z transform of n? Z by z minus 1 the whole square. Next is just a constant, don't leave that as it is. So though it's 5 into z transform of 1, so 5 into z by z minus 1. So we have applied z transform on both the sides. Now we don't have initial values to substitute for, so directly we are going to segregate. So first to take all u bar of z terms constant, so now if I take u bar of z here, what we will get? If I take u bar of z, this coefficient is z square, we have written. Then again u bar of z is here, minus 2z we have written. Final one more u bar of z is here, plus 1. So z square minus 2z plus 1 into u bar of z. So once you have taken these terms, just put a tick sign that you have used these terms here. So now we are going to take all the u0 value. Okay, so what is the u0 first coefficient? Minus u0 into z square. So if I have taken minus u0, what I will be left only with z square. Again we have one more u0 over here, so minus 2z into minus u0. So if I have taken minus u0 means, then I will be left with minus 2z, because this minus and minus will become plus, same thing. So we are done with u0, and finally only one u1. So z square minus u1 into z power minus 1. So z square into z power minus 1 will become z. So final term is minus u1 z. And right hand side it's going to be the same, 3 into z by z minus 1 the whole square plus 5 into z by z minus 1. Okay, so now leaving the term u bar of z, all the other terms we are going to take it to the other side. So that is why we have taken negative sign common. So if we take negative sign common, if I push it to the other side, it become positive. So this became u naught into z square minus 2z plus u1 into z plus these two terms. Okay, now see this side, z square minus 2z plus 1. This is nothing but z minus 1 the whole square. So this z minus 1 whole square into u bar of z we have. Now we have to write what is u bar of z. So u bar of z is equal to u naught z square minus 2z by z minus 1 the whole square plus u1 z by z minus 1 the whole square plus 3 into z by z minus 1 the whole square. Already this z minus 1 whole square will become z minus 1 power 4 plus 5 into z by z minus 1 the whole cube, because this is z minus 1, so it's z minus 1 square. So now you can take these two terms and we can simplify, that is z minus 1 square in the denominator we have, yeah. So if u naught and u1 is given, then we would have simplified these two terms because it's just going to be a number. So since u naught and u1 is not given, I cannot combine these two. So u naught into z square minus 2z by z minus 1 square plus u1 into z by z minus 1 square, but I can combine these two terms, just constant, and here z minus 1 whole power 4, right? So here 5z into z minus 1, and then here plus 3z, and if you simplify you will get 5z square minus 2z by z minus 1 the whole power 4. This is just LCM, you can show that also. Yes, you can see that actually this is the term 3z by z minus 1 the whole power 4 plus 5z by z minus 1 cube. So multiplying numerator and denominator by z minus 1. So denominator becomes z minus 1 power 4, and here 3z as it is. If you multiply 5z square minus 5z. So if you simplify, what I will get, 5z square minus 5z plus 3z. So I will get minus 2z by z minus 1 the whole power 4. This is what we have got there. So now if you see, we have got u bar of z is equal to u naught into this term plus u1 into this term, then finally our simplified term. 3 terms we have. So this is nothing but p of z, this is nothing but q of z, and this is nothing but r of z. It's like 3 problems on the right hand side. You are going to apply inverse z transform. So find this separately, find this separately, and find this separately. Finally you are going to substitute back. Okay, so if I take this first term p of z, z square minus 2z by z minus 1 the whole square, how we will resolve it into partial fractions? See here, that is a z by z minus 1 plus b z by z minus 1 the whole square. For these two things I want only z in the numerator, nothing else. So here I can take z minus 2 into z. So I can preserve z and bring it back later, or we can write it simultaneously. Whichever way you do, answer is going to be the same. So in case if I am not taking z down, okay, like the other way, what I am going to do is z square minus 2z by z minus 1 the whole square is a z by z minus 1 plus b z by z minus 1 the whole square. Now if you take LCM and cancel z, okay, if I cancel z, what I will get, z minus 2 on this side. If I cancel z, denominator 1 z minus 1 is there, so z minus 1 square is that is what we wanted in the denominator. So multiply numerator and denominator by z minus 1. So a into z minus 1 plus b. There is no z, these two z terms, and here whatever z we are taking common will get cancelled, like whatever we have done so far in partial fractions. And if you substitute z as 1, a will become 0, and here b will become 1 minus 2, so b will get minus 1. So we got b here, and how we will get a? Actually it's very easy. Comparing the coefficients, as I told you, coefficient of z is a, here coefficient of z is 1, a is equal to 1 over. If I substitute z as 1, I will get b, If I compare coefficient of z, I will get a as 1. You can note it down. Comparing the coefficient of z, we got a as 1, and substituting z as 1, we got b as minus 1. So we got a and b for this first term. So now we are done with this part. Okay. Now we are dealing with the second term. Okay. And if you want, finally you can take inverse, or for each term we can take inverse separately. We will get the answer and we will substitute. It's up to you. So if I take inverse for the first term, a we got 1, right, z by z minus 1. So z by z minus 1, it is nothing but formula is 1. And b we got minus 1, so minus sign is here, z by z minus 1 the whole square. What is the formula? It is a formula for n. So we are done with the first part, inverse also. Inverse value is 1 minus n. Now you can substitute the value directly. So now coming to the second one, z transform inverse of q of z, that is z by z minus 1 the whole square. Is there any need to resolve it into partial fractions? No, already it's in the formula format. So z by z minus 1 the whole square, z transform inverse of it is nothing but n. So we are done with the second term also. So just now we resolved this into partial fractions. Then this term we saw z by z minus 1 the whole square. So if I take inverse z transform, this is nothing but n. So now we are left with only this final term. So before solving this problem itself, we will try to find out which formula it will fit in. So 5z square minus 2z by z minus 1 the whole power 4, right? If I resolve the denominator into partial fractions, what I will get? Z minus 1 square, z minus 1 cube, and finally z minus 1 power 4, correct? Because its power is 4. So z minus 1 in the denominator, I can write the formula. It is z transform inverse of 1. Z minus 1 whole square in the denominator means, like previous one, it is z transform of n. If it comes to z minus 1 the whole cube, how the numerator should be? Z square plus z. Then only it is nothing but z transform inverse of n square. If it's z minus 1 the whole power 4, the numerator should be z cube plus 4z square plus z. So you remember, we are going to set the numerator according to the denominator. So now coming to partial fractions, this is the question. So we are resolving, already we have given the name A, B, C, A and B. So we started from C, nothing special. So C into z by z minus 1 plus D into z by z minus 1 square plus E into, what is the third term? Z minus 1 the whole cube. So what do I want in the numerator? Z square plus z, because I want to apply this formula. And finally plus f into z cube plus 4z square plus z by z minus 1 the whole power 4. So far we have seen problems with the k, right? So here it is z minus 1 in the denominator. So that's it. So in the numerator we can take z common on both sides. Here if I take z from the numerator, what I will get? 5z minus 2 we have written. If I z get cancelled, I will get c. Here also z get cancelled. Here if I take z common, I will be left with z plus 1. This is what we have written. And finally if I take z common here, I will get z square plus 4z plus 1. That's it. We are taking z common and cancelling it. Left over is the LCM part. So LCM denominator z minus 1 power 4, right? So 1 z minus 1 is there in the denominator. So we are multiplying by z minus 1 the whole cube. Multiplying as well as dividing it. So the division part will get cancelled. So we are seeing only the numerator. Z minus 1 square. So which is missing? One more z minus 1 square is missing. So multiplied by that. Z minus 1 cube, which is missing? One more z minus 1 is missing. So multiplied. And finally this has got all the terms, right? So we are leaving it as it is. So what we have done, we have taken LCM, cancelled the denominator and taken z common from both the sides and cancelled. That's it. Now all these things you know already. If I substitute z as 1, this will become 0, this will become 0, this will become 0, I will get f value. Okay, simplify and find it. So 1 square plus 4 plus 1. Okay, so 6f is equal to 5 into 1 minus 2. That is 6f is equal to 3. Therefore f is equal to 1 by 2. We got it. Okay, so hereafter we can compare the coefficients. So if we compare the coefficients of z cube, z square and z on both sides, we are getting these equations. Okay, what is the coefficient of z cube here? C z cube. Here there is no z cube, 0. C is equal to 0 over, comparing the coefficient of z cube. Okay, so what is the coefficient of z square? For coefficient of z square we have to work out here. Here left hand side is nothing, 0, there is no z square. So 0 is equal to, and here if you expand this, okay, minus 3c z square will come. So minus 3c we have written, and then here plus dz square, so we have written plus d. Here e z square plus e plus f z square plus f. Only this you have to work out. Z minus 1 the whole cube, if you expand, coefficient of z square only you have to check and write. So this is one equation, let it be. Compare the coefficient of z on both sides. What is the coefficient of z? 5. So we have written 5 here. And here what is the coefficient of z? I'll get plus 3c, because a minus b the whole cube. So because of this negative sign, one term will become positive, one term will become negative. So please be careful with the formula. So we get 3cz. So 3c, and then here a minus b the whole square, so minus 2d, and then here one negative, and there is no z term here, because plus z and minus z will get cancelled, no z, no e. And finally what is the z term? 4z. So 4 into f we have written, that's it. So this is coefficient of z, and here there is no e value here. Okay, you can substitute f value also. F value is 1 by 2, correct? So in this equation I know what is f, we know what is c, so we can find d directly. So minus 2d plus 4 into 1 by 2 is equal to 5. So we get d, and finally in this equation we get, we know what is c, what is f, so only d plus e combo we will get. So from this we can get e. So we got d and we got e. So finally we have to apply inverse Z transform. This is very easy because already we have done everything in the formula format. So first term c is 0, so this term will become completely 0. So we will go with the second term, z by z minus 1 the whole square. Coefficient of d is minus 3 by 2. So z by z minus 1 whole square formula is n, and here e term, e is 1, okay. Z transform inverse of z square plus z by z minus 1 the whole cube. What is the formula for z square plus z? So it is z transform of n square, and this is z transform of n cube. Just coefficient of e is 1, coefficient of f is 1 by 2. So 1 into n square, 1 by 2 into n cube, that's it. Here it is. So minus 3 by 2 into n plus n square plus 1 by 2 into n cube, we are done. So because of the c 0, d is minus 3 by 2 we have written, inverse of this term is n, e is 1, inverse of this term is n square, and f is 1 by 2, inverse of this term is n cube. So we got the Z transform inverse of this. So we had 3 terms initially, right? So we are going to write Z transform inverse of all the terms together. Yeah. So the first one is u0 into first term p of z, second term u1 into Z transform inverse of q of z. This is a direct one, so we didn't resolve it into partial fractions. Third term is Z transform inverse of R of z. So first term answer we got u0 into 1 minus n, second term answer is a direct one, n, third term answer just now we have derived now, n by 2 we can take common, n square plus 2n minus 3, that's it. And after this is just a simplification. So what we have done is, because we don't know the value of u0 and u1, right? So we are segregating the coefficients and finally calling this as some constant c1, and minus u0 plus u1 minus 3 by 2 into n. So these are all just constants, right? Giving another name c2 for this, and we can say that these are all arbitrary constants. That's it. So this is the solution. So if u0 and u1 is not given, means the problem is going to be little lengthy. because as I told you, if u0 and u1 is given, this problem itself, it's easy for us. We can put it together as one term and we can simplify it. Okay. So finally, you will even if how many terms are there, you will resolve it each one into a simple problem, and then we will be finding the inverse for the same. Thank you.